In this first descriptive geometry lesson, we're going to learn how to use Monge's procedure to find the third view of a line segment. Right now we see two views of a line segment. What we have in this picture, let me introduce some of the elements. This here is called a folding line. And we have another folding line down here. The black lines are the folding lines. And they're separating out three principal views. I want to give these terms or define these terms in some sense. Principal views, and we have three of them. H, you see that H indicated over there? That is called the plan view. It's a horizontal view, a top-down or bird's eye view. And then we have F is a front elevation view. If you were looking front elevation view. Okay, and then P is indicating the profile. We were looking at the profile of the line segment. And that's the third type of principal view. So we only have three principal views: profile views, front elevations, and plan views. Later on we'll learn about other types of views called auxiliary views, but right now we have just these principal views. And our goal is to find out, what does this line segment look like in the profile elevation view? So I'm going to write that down. Find the profile view of the line segment. And the first thing we're going to do is label the ends of the line segment. And I want to use a different pen at this point. This is kind of a thick pen I have here. I'm going to call this A, and I'm going to call this B. And if that's A there, then looking straight down, this would have to be A here. I'm arbitrarily choosing those labels, A and B. They don't always have to be called A, B. I could have called it 1 and 2 if I wanted to. But I'm calling it A and B. The first step, step 1, is to draw what we call projection lines. Draw projection lines. I'll explain what that is here in a second. Draw projection lines into the profile elevation view. I'll just call it profile view here. But draw projection lines into the profile view. What's a projection line? Well, projection lines will come from A and go into P this way. Now I'm going to do a better job than that, because that's not very neat. We want to have some degree of accuracy here. So I'm going to use a straight edge. Okay, so I'm drawing this projection line. And how far in should I go? I'm going to take it in there a pretty good distance, making a light kind of dotted line. My electronic pen here, if it did a finer line, I'd be in better shape. But you know, so this is how you do it on your own paper. And do the same thing from B. Nice little light projection lines. So these guys are called projection lines. And again, they're at a 90-degree angle with the folding line. I want to get this little messy thing out of there. Okay. So now that we have those, we can go on to step 2. Okay. Step 2. For step 2, we will plot points A and B in the profile view using distances from the plan view. Now, what does this mean? Well, okay, so what I'm saying here is somewhere along here, somewhere along this projection line from A, in this new view, in the profile view, it's somewhere in this area, I'm going to plot A. Should I plot A here? Should I plot A here? You know, where does A go? I always, whenever I'm in a new view and I want to find out where where to plot the point, I skip this first folding line and I skip this folding line. And it is in that second view that I've skipped into that I will find the distance. And what I mean by that, let me get a red pen going here. The distance to A, I'm going to grab that distance right here. So this is the distance. I'm calling that distance 1. An eighth plus a half. And so it's landing right here. I'm going to label that immediately, label that A. And then B, see if you can see, how far in should B? Should B be closer here, or should it be further out? What do you think? Give yourself a moment to determine, where do we find the distance to B? Well, we're going to do the same thing. We're going to, if we're in this profile view, we're going to skip the folding line to this B, and then we skip another folding line, and it's going to be found in the same area, in the plan view. And so this, right here, this distance, it's the distance to the folding line. I'm calling that distance 2. That's the distance to the folding line. It's not the distance from B to B. Some students make that mistake, or they'll take the distance from A to A. It's not that. It's the distance from B to the folding line. And using my architect's scale, I see that it's over an inch in, and I'm getting an accurate measurement, and B lands right there. Where did I get that distance? I got that distance in the plan view. So that distance that you see labeled D2 is right here. I should have done that on the first one. That was distance 1 that you see, and this is distance 2 down here, taken from the plan view. So now, and I should label this immediately, that's the line segment AB. Now that I'm done, I can connect A and B using my straight edge. And that is the profile view of AB. It's a skewed view. It's, you know, we're seeing a completely different view of it. It's a different skew. I should also say that no line here, no version of the line segment AB is true length, and we'll learn about how do you find the true length. How do I know it's not true length? That'll be the next lesson.